With version 10, we're introducing hooking up to a GIS systems. Again, at the What's New in version 10, we went through this a little bit, but we've actually, again, we've got one of our users who's been a beta site for this, will actually talk about how they're using it in practice. For those who just don't understand, just quickly what it's all about is being a hookup from 12D into a GIS database, such as Esri Arc, so that you can actually download data from there, and this is much rarer that your GIS people let you upload data. Most people are not allowed to do that, but it is possible. The two types of data you might want to be able to get on demand out of your GIS systems. One is vector data, which is the sort of thing like cadastral boundaries, information, points, because a lot of places they're storing things like point clouds inside their GIS system, and so you go pull out a little region of it. The other though is rasters, background rasters. So you may have all your plan rasters that you'd use as your backdrop. They could be in your GIS system. But when we use those, you can actually hook up live. So actually, as you pan around 12D, your background image photo you're getting is actually coming live from the database. The vector data, you pull that down and then it stays inside 12D. So there's two things going on there. But basically, that's the idea. So your GIS system is hooked in the background. Things come out without you really having to worry too much about how to do it. So you can download geometry strings, things like that. As say rasters or aerial photos, we should say, is the major one for that on the fly as you move about. And we can bring down attributes from the GIS system into 12D. And we can map them. That's the biggest problem with GIS systems is first their attribute system's usually pretty primitive. There's only one level and you can usually only have it on a point or maybe on a polyline. That's about it. So you have to make some decisions about how you're going to get your data into 12D and how you want to map it back. But basically, from a GIS system, we just can pull down all their attributes. You can work it out later. So basically, it's fairly straightforward, that part of it. An example here from Bundaberg, which we'll be talking about shortly. The background raster there, the photo, is coming live from the GIS system. And if people recognise, we did this this was from the 2010 conference, where we were hooked up live to Bundaberg, and they were pulling this live from their system. All the purple is cadastre, and the other things we pull that down as vector data, and with all the attributes that went with it. So at the 10, we're talking about what's going to come in version 10 at the 2000 conference. This is now released. When you bring down your vector data, it has lots and lots of different attributes, and you then can do some things with them. So you might then run other practice things, macros and things, to make sense of the data. The query, when you're talking to a GIS system, the query is only what your GIS system allows us to do. Because the thing about GIS is you might have billions and billions of things in there. So you might say, I've got a rectangle. The GIS system will say, look, just give me that data. Don't give it all to me. So you're using your GIS system to selectively get data out of it. So what you can do there depends on what your GIS system supports. So different GIS systems support different things. But there's various queries you can do. They could be spatial, so I only want things inside this polygon. They may be by picking attributes of certain names. And again, how many of those different things are available will just depends a little bit on your GIS system. Uploading, so you get data in 12D and upload it. Again, the GIS people don't usually do that live, although at Bundaberg, they are actually allowing that to happen, which we'll mention about that. And we have mappings from 12D model names and things to go into it. But that's the interesting thing with GIS systems. They're as dumb as they come. Most of them don't even have 3 dimensions. So they don't have that sort of information. So usually if you've got an attribute in 12D and it's got various levels, you've got to say, well, how is that going to be represented inside your GIS system? So you have to talk to your GIS people to figure out how is your data being stored in their system. And every system is different. So we have to sit down and we have to talk to the GIS people about how are you storing a pipe? Because they don't have pipes. So they've probably got an invert level stored as one attribute. At either end, they might have thickness as some other attribute, and you have to know what those names are. So we set that up in the beginning, but after that it's pretty straightforward. The transformations, basically this is where if you are going to have data going up in a GIS system, you tend to be more running some processes in 12D to get the data into the right shape and then uploading it. So and that's what we have macros and things like that to do, so that can go on the background in a chain and be done automatically for you. Once they're set up once, it's usually okay. And similarly, when we're getting data out, you usually have to do some things to turn into data we can understand. So it takes your invert level, and a 2D pipe, and we turn into a 3D pipe with diameter. So that's a process we can then run and do it. And some, like most GIS systems, I think arcs have no arcs. And so you've got to decide what you do in those situations. Well, they don't have arcs. And there's single level attributes. So basically, we just have to think about those things in advance. And once you've gone through that, it's very, very automatic for the users to get access to the data. Now, so just mentioning some of those things I spoke about there. So if you just think about this when you're talking about your GIS, first, the GIS people won't know who in hell you are. They don't know what goes on outside the GIS world, so they don't even know the surveyors and designers even exist. So you've got to go and tell them who you are, and then figure out how their data is stored down there, and then just talk about what these mappings are, the transformations to get between the two systems. Once that's all been sorted out, it's very smooth sailing. But just be aware that they probably don't even know you exist. But once they show you what you can do and you can communicate with them and get the right mapping, everything's very, very simple and goes fairly sweetly. Right, various server types. Again, we connect to some of them. They have to have a certain thing for us to be able to use them, but Arc SDE is one of them. Enterprise databases like MySQL, SQL Server, Oracle, Oracle Spatial. What's that one? PostgreSQL, SQLite. Autodesk SDF files. So actually some of these files can be considered as a database. So if you actually have Esri shape files, they do have information in them. So you can access with this just like you at a database. But if you've got an Esri shape file, it does not have any intelligence. So you couldn't have a query on that to say, oh, only give me the things inside a certain element or inside a certain polygon. Because the shapefile just can't do that transaction. You'd have to pull that all into 12D and then do your processing and selection inside 12D. So that's Esri shapefile is considered a very simple GIS database. But that's where, yes, what queries can it do? Web feature services, that's vector data. Web mapping services for bringing down plans and rasters. So basically, all those sorts of things you can handle, and we just have to talk to you about them, how they're going to work.